So while okay, this is my presentation. Yeah, thank you for the opportunity to address the audience. My presentation deals with the LEO system called Marathon, meant for IoT applications. This project has been developed since 2018. Now, it is part of the so-called Sphera project run by Roscosmos State Corporation. ISS Reshetnev deals with the satellite segment, VisatTel for system solutions, and for the ground segment. This is a rough design still, and about 15 companies are involved in working on this project. I will not name all those companies. MTS and Art Telecom Holding are just two of them. They are actually ground operators. And I want to tell you that development of satellite telecommunications depends on its integration with ground networks. The integration of ground networks and satellite networks. Well-established ground technologies can be adapted to satellite, to outer space uses. Next slide, please. So why marathon? Before answering this question, I would like to point out that today there's some misunderstanding. LEO system, broadband access, and LEO IoT systems are something different. They are different from LEO, just LEO systems. LEO IoT is something different. Broadband LEO systems is a cul-de-sac, is a blind alley. And that was said as long ago as in the 90s. Having analyzed all the trends and tendencies, we concluded that today IoT, satellite IoT, already exists. It's offered by Iridium, Global Star, and so on. But having analyzed the development of this area, we concluded that this is going to be a blind alley. Mobile communications, mobile satellite communication is not good for IoT applications. The reason is that terminals cost hundreds of dollars, traffic is expensive, the operating parameters of subscriber equipment is totally unacceptable from the viewpoint of IoT applications. Having analyzed this situation, we understood that if we want to develop satellite IoT, it must be competitive. It must be competitive in terms of prices, in terms of functions, and it must be competitive with respect to ground systems and LPWAN systems. This slide shows that the prime cost of a device is $10 to $30, ARPU $2 for standard, and $8 for online mode per month. For standard solutions, we expect to use the same subscriber terminals as in the ground networks, using ordinary batteries and weighing grams and being no larger than several centimeters. So it is impossible to develop satellite IoT applications without adapting those protocols and technologies used in ground networks to assess outer space uses. We have analyzed all available technologies, and the only technology that may be tailored, may be good, is the LoRa technology, which is reliable in terms of Doppler. Another point, there are a multitude of IoT projects. Most of them are not good because the lifetime of satellites is not more than 2 years, and nobody can establish a reliable constellation for reliable service. And the power systems of such satellites is not adequate, is not high enough, is not. Next slide, please. If we mention marathon IoT as we see it now, the key objective is to provide satellite IoT services and integration of ground and satellite channels, links. The constellation itself will consist of more than 200 satellites in polar orbits. Back, please. Spacecraft mass is 45 to 50 kilograms, polar orbits 750 kilometers altitude. It will act with end devices, so to speak. Also, we are considering optional functions such as the field of control, unmanned vehicles, and transmission of commands to such unmanned vehicles. Collection of data gathering from sea vessels, from aircraft, and another function is the transmission of signals in the GLONASS system, and finally, maybe geolocation. The geolocation function will be added. Next slide, please. This illustrates such things as a multitude of satellites which gather data and retransmit this data to regional interfaces, gateways. In Russia, 3 such gateways are sufficient in each region, and then the data will be distributed further via other systems. So this makes up a regional operator, a virtual operator in each region with its own coverage or we can shape a different area, 4,000 kilometers by 6,000 kilometers. Also, it is important that each satellite can be accessed individually, not only from Russia, but from other territories, so we can implement inter-satellite links between Marathon and GoNets to transmit control systems to avoid collisions. Collisions is a serious problem nowadays. It's been discussed for several years already. So all future satellite constellations will have to have a function to avoid collision with other small satellites and to avoid collision with space debris. Next. As I already told you, the key objective of IoT Marathon, IoT as we understand it in the case of ground networks. This slide shows technical parameters which prove that we use the same subscriber terminals that are used in ground networks, same subscriber devices. Maybe the antenna will be a little bit different polarization and different elevation angle, and this will help us integrate the satellite segment with the ground segment. And it is also important that the power margin is 7 to 8 dB, which makes it possible to use satellite radio links from indoors. Next. These are standard services to be provided by Marathon IoT. I will not go over the whole list. I will just point out that logistics and control of supply routes will be the most advantageous application, economically advantageous, and control of emergency situations is a very important government task. Alarm buttons is a very important social task. So this is potentially wide application area. The Marathon IoT system produces a synergy effect. We are now, if we take, for example, forest fires, we are now developing sensors to detect forest fires. If a fire occurs, breaks out, then we can use a remote sensing satellite. We can tell a remote sensing satellite to look at a specific area where we suspect a fire is developing, to look what is actually happening. Next slide, please. These are the optional services again, once again. These are marine and unmanned systems. And the last one, control and command to launch nano and micro satellites. We think that this last area, nano and micro satellites, commanding control, is very promising. Other functions are listed here on this slide: aircraft tracking of sea and river vessels, geolocation of IoT devices. And the next slide. This is the general block diagram structure. This is a space segment operator, a terrestrial operator, some international management company, and a coordinating center. Operators of terrestrial networks, we expect they will cooperate, as we rely on potential cooperation with terrestrial operators who will, in their turn, provide services to end users. And where terminal subscriber devices will be used. I think that satellite IoT is a new market that doesn't exist, but that is emerging gradually. If we achieve those cost indicators, those prices, the system will pay back within 3 to 3.5 years, based on 4 to 5 years as the active lifetime of satellites, making the system commercially viable. Next. Here, I would like to draw attention to the fact that we are open to cooperation with all those companies that are interested in promoting such type of system, and we will be delighted if you contribute your ideas to our project. We hope that our cooperation will expand. I think that this area, this is a promising area, satellite IoT. Thank you for your attention.